So as we were talking about before, the multiple spanning tree protocol, or MST, the main idea behind this is that we can manually define what are the number of spanning trees that we want to run and how are they going to map to the individual VLANs, which in this case we're considering them these multiple spanning tree instances that are separate from the actual VLANs. So the design and the configuration for this is that first off we need to make sure that everyone agrees on what the instance to VLAN number mappings are. Additionally, we need to make sure that the switches are in the same region. This means that they're participating in the same number of instances, where that design where we have a very large scale network and we want to treat them as independent calculations, that would be when the switches are in different regions. But for the vast majority of implementations, like in the enterprise, you would have all of the switches in the same spanning tree be part of the same region. So let's look at an example of this now where we have 6 different VLANs. We have VLANs 10, 20, 30, 40, 50, and 60. So with our previous configurations, then the first step for this would be to configure the VLANs to make sure that everyone actually has the MAC address tables allocated. Since I'm already running VTP, and we can see this from the show VTP status, if everyone is in my same VLAN trunking protocol or VTP domain, I should be able to simply define these VLANs 10, 20, 30, 40, 50, and 60, and then look at on the other switches the results of the show VLAN output. And we should see that everyone agrees on this. So again, the MAC address table is always going to be directly related to the VLAN. What spanning tree is doing for us is to determine which ports can we learn MAC addresses on and which ports can we not learn MAC addresses on. The end result of which interfaces we can learn them on is going to be how we actively forward the traffic through the layer 2 network. So in the end, the switches are just based on that fairly simple logic. Then when we look at the show MAC address table dynamic for any particular VLAN, traffic is going to forward based on this. So now we have our VLAN instances defined. If we look at the show spanning tree, we can see right now we're running the rapid spanning tree protocol. This was configured when we look at the show run include spanning tree. Just a single command, the spanning tree mode is rapid per VLAN spanning tree. This means for each of these 6 VLANs that I now created, 10 through 60, there's going to be a separate instance of spanning tree. If we look at the show spanning tree summary, that's what I'm looking for. This is going to show you how many instances you're running. In this case, there's 7 total. There's one for the default VLAN of 1. Then there's an instance each for VLANs 10, 20, 30, 40, 60, etc. Now for the multiple spanning tree protocol, before you actually turn it on, the first thing that you need to do is to make sure that all the switches are ready to agree on what are the number of instances we have and what are the mappings to the individual VLANs. So it's a 2-step process in the migration, where we would say for the spanning tree MST configuration mode, under here, this is where we define mainly 3 attributes. What are the instances that we have, and what particular VLANs are they going to correlate to? What is the name and what is the revision number of the region? These 2 are basically arbitrary values, but they have to agree on all of the switches that we want to run the same spanning tree. So I could say that the name is region 1, and the revision number of that region is anything, 1. But the end result of this is that all 4 of the switches, I need to make sure that this matches. Then we would define the instances. For the first instance, I want this to map to VLANs 10, 20, and 30. For the second instance, I want this to map to VLANs 40, 50, and 60. There's also going to be an instance 0 that is the default one. For any VLANs that I create that I don't manually map them, they're going to fall back to this instance 0 as a default. In this particular design, that would be VLAN 1. If I don't put VLAN 1 into one of these manual mappings, it's going to fall back to 0. So before making any other changes, I need to now make sure that all of the switches agree on this config. So you essentially take this and put this everywhere on all the layer 2 switches. A final step would then be to actually enable the protocol. If we start at the top of the design here, we'll start on switch 1 and work down. As you enable the protocol, the rest of the network is still running a different version. They're running rapid per VLAN spanning tree. What the result of this is going to be is that if we say the spanning tree mode is now MST, is that switch 1 is automatically going to be running the interoperability of the multiple spanning tree protocol to rapid per VLAN spanning tree, or if we were running the legacy common spanning tree, it's going to know that these are what we consider boundary ports. And on the boundary ports, we need to basically make it look like we're running the legacy protocol. We can see on switch 1 it generated an error message here. It says that there's an inconsistent inferior per VLAN spanning tree BPDU received on VLAN 10, where they were claiming to be the root bridge. And let's look at the configuration of the other switches. If we show run include spanning or spanning tree, this is one of the common design problems you can run into with the protocol, that in order for the interoperability to work correctly, the root bridge information has to be inside of the multiple spanning tree domain. So if someone down here is running a common spanning tree, or they're running per VLAN spanning tree, and switch 4 is claiming itself to be the root bridge, the new multiple spanning tree domain is not going to be able to run with this. So essentially this switch would then be isolated from the layer 2 network. And from an application point of view, it means you're not going to have reachability to any of those end hosts. So you need to look at your overall network design and figure out where are my root bridges placed now, and figure out how that's going to fall into the migration, that the root bridges always have to be part of the MST. This is why switch 1 is giving us that error message. It's saying that someone claimed to be the root for VLAN 10's instance, where the device that did this, let's look at the MAC addresses. This was the MAC address of switch 4. And on switch 4, we don't have a priority configured, so why would it be, let's see, blocking the root port fast Ethernet 13, inconsistent inferior per VLAN spanning tree BPD received on VLAN 10.
Based on MAC ID, the MAC address.
Let's see, what is port 13 in this topology? Port 13, actually port 13 is this one. So what happened is that when this switch started to run multiple spanning tree, switch 2 said that the root was down here, and this isn't valid, so it had to disable that interface. On switch 1, if we now look at the show spanning tree, The change is now it says that we're running multiple instances, where as opposed to grouping these based on the VLAN number, they're grouped now on the instance number, where this instance number, this now becomes the system ID extension. So instead of using VLAN 10 for the identifier, we use whatever the MST number is. Like this one here becomes 0. It says these two ports connect to the boundary of the per VLAN spanning tree, but the problem is that this is inconsistent with my topology. So even though this is supposed to be the root port, it's actually denied from sending traffic, and now it's blocking. This asterisk is kind of a warning here saying that something's wrong in your design. Spanning tree can't calculate the topology the way it's now, which ultimately will be fixed once everyone agrees that we're running the same type of spanning tree. The spanning tree mode is MST on everyone. The problem is that while you do this migration, you could have some problems. Switch 1 eventually should report that these interfaces are going to be no longer inconsistent. It says the inconsistency was cleared, so now it's okay. If we look at the resulting change now and say show spanning tree, we should now see that there are 3 total instances, 0, 1, and 2. Where 0 is going to be any of our default VLANs, like in this case it's VLAN 1. Instance number 1 is where I have VLANs 10, 20, and 30. Instance number 2 is where I have 40, 50, and 60. This on its own, you can see, looks fairly similar to how it did before, but one of the main changes is that the cost values are more granular. This allows for the growth of our 10 gig Ethernet interfaces, or the 40 gig, or for the 100 gig and beyond. That previously it was saying that a 10 gig interface was something like a cost of 2, which doesn't really give you much growth to have higher speed interfaces and then really be able to tell the difference between them. But the logic is still going to be the same, that as the bandwidth of the interface goes up, the cost value is going to go down. To change the topology, it would then be the same logic, that the calculation is based on who is the root bridge to start, which is going to be based on their priority, their MAC address. Then once the root is elected, what is my lowest end-to-end cost in order to reach them? So in this case, this is not switch 2 or switch 1 that was elected. It's probably going to be switch 4 because I think it had the lowest MAC address. So on switch 4, if we show spanning tree MST, this gives you a little bit more information about what VLAN numbers are mapped to the instances. This instance 0, you can see it's basically everything besides the ones that I manually pulled out. So if I create VLAN 41 later, it's automatically going to fall into this calculation. But for instances number 1 and 2, these are 10, 20, 30, and 40, 50, 60. It says the root bridge for MST instance 1 is me. Likewise for instance number 2. Because when I compare my MAC address and my priority value, the combination of these two ends up that I have the lowest values. Where the priority is the same as it was before. It's the default value of 32,768 plus the system ID extension. But now this number is coming from the instance number, which basically means that these 4 switches are falling back to just the MAC address. And switch 4, it has the lowest address of the 4 of them. So it's going to be the root for both of these instances, actually all 3 of these instances, 0, 1, and 2. But now the key is that from here on out, if I wanted to change the topology, I'm going to be changing it on a per instance basis as opposed to a per VLAN basis. If I wanted switch 2 to be the root bridge for this first instance, what would I want to change? If I want to make this one the root for instance 1, I would change the priority. So if the priority is lower on switch 2, if I set it to 0, for example, that would be the best priority. and it should say that I'm going to be the root for that particular instance. The syntax structure you'd see is fairly similar. The difference is that instead of saying spanning tree VLAN and then the number that you want to change, you say spanning tree MST and then the instance number you want to change. So I would say for instance 1, set me to be the root. And I'll be the current root, the primary root. Or on switch 3, if I wanted it to be the root for instance number 2, I could say for spanning tree MST2, set the priority value to be a lower value. Let's say 4096. Okay, you'll also see that it asks you for increments of 4096. This makes sure that your system ID extension plus this value ends up to be unique. But if I were to say 4096, this should be lower than any of the other bridges. So now on switch 3, if we were to look at the show spanning tree for MST instance 2, now I am the root, which means that all of my ports are designated. They're all facing downstream away from me. If we look at the calculation of the other bridges for this specific instance, it says now switch 3 is the root for MST2. Switch 1 is then going to look at what's my cost if I go this way, or what's my cost if I go that way. So the logic of the topology is still the same. What's changing is that we have that rapid synchronization process between the bridges, and that we don't have one instance per VLAN. So on switch 1, if we were to say show spanning tree MST2 detail, the key fields that would be important about this are what is my identifier, what is the root's identifier, what's my root port, and what's my cost to reach the root. So if I go out port 16, my cost is 200,000. This is what a fast Ethernet interface is getting by default. So fast Ethernet here is 200,000. This one likewise is 200,000. And over here, and over here. So if I were to go in this direction, my end-to-end cost would be 600,000. If I go in this direction, it's 200. So just like before, I'm going to pick whatever the lowest value is. This means that from switch 1's perspective, this should be the root port. For instance number 2, this should be the designated port that's facing downstream, away from the root. Switch 4 should say the same thing, that my closest path is this one via 200,000, which really means that the only device that needs to now make a decision is going to be switch 2. I'm going to choose one of these ports as my root. The other one is then going to be what? It's going to be the effect of blocking, it's going to be discarding. But what's the port role going to be? One of them is going to be root. Another one is going to be alternate, because that's basically a backup path to the root bridge. And the key then is that if my root port goes down, I can immediately transition to the alternate port, because I pre-calculated that that's also a loop-free path. So let's look at the detail on switch 2. Let's say show spanning tree. Show spanning tree for MST instance 2, and look at the detail. It says there's 2 ports. There's number 13 and number 19. This one is blocking, okay, which really is discarding. They're calling it blocking here. Same difference. This one is the root port. So why are we choosing this as the root port as opposed to this one? Would be the same type of process as before. I need to know what is my cost on the link. This is my local cost. Then I'm looking at what is their cost upstream. So the next top neighbor is using 200,000 to reach the root. If I have 200,000 to reach them, it means that if I go through this path, it's going to be 400 total. This one likewise is going to be the same. If these two values are equal, then I need to look at what? Who is the lowest upstream bridge ID? So now I'm going to compare these two values. I have 0019 versus 000C. That's why this one is now elected the root. And actually, I look at the priorities first, but those are the same because I didn't change them. So the same type of logic, you look at the cost. Then if the cost is equal, then you look at the upstream bridge ID, which the bridge ID, again, is the priority, the system ID, and then the MAC address, where the priority and the system ID for these is also a tie, so I'm using the MAC address as the tiebreaker. The end result of this would be that if I were to look at the show MAC address table dynamic for VLAN 10, once I actually have hosts in this VLAN, like in this case I have router 2 here, let's say also that, so router 2 is in VLAN, or not in VLAN 10. I would need to say in, let's say it's in VLAN 30. Switchboard access VLAN 30. Then on switch 1, I'm going to put router 1's port into that same VLAN. Switchboard access VLAN 30. No, I'm not 30. That's in instance 1. Let's say 40. So this portion of the configuration in the design is the same, that you just want to make sure that the hosts that are in the same subnets, they should be in the same VLANs. They want to be in the same broadcast domain. So router 2 now, I have it as part of VLAN 40. Router 1, I have it likewise as part of VLAN 40. I have two instances of spanning tree, MST1 and MST2. MST1 is VLANs 10, 20, and 30. Instance 2 is 40, 50, and 60. So it means their path selection, or basically their CAM tables, is going to be controlled based on the MST2 selection. If I go to send traffic between the hosts, let's say on router 1, I ping 10.0.0.2. When switch 2 looks at the MAC address table and looks at where the MAC address of router 1 is located, it says this is on port 19, because why? Because that's the root port. So even though physically it would make more sense for them to use this connected link to forward, that's not what spanning tree is allowing. Spanning tree is saying this port is blocking because this neighbor here had a lower MAC address than this one. So that the MAC address table, when I look at anyone in VLAN 40, is going to go this direction. But let's say we don't want to do that now. I want to change the path selection so they're going to use the closer links. That for router 2 to get to router 1, I want them to go directly between these two switches. The root is still here, though. This means that from the root's perspective, these are always going to be designated ports. If I want the traffic to be able to use this link, then what do I need to do? Which link is going to have to be blocking? This one is going to have to be blocking. Now, technically, I could get the tree to be built in this direction. That would also work. But as long as both of these interfaces are in the forwarding state, that would allow the traffic to go over that link directly. So on switch 2, if I were to say that the cost of this link end-to-end is lower than the cost of this one, so let's say I set this interface to be 100,000 as opposed to 200,000, So now I'm looking at 100 plus 200, or a total of 3, versus 200 plus 200 for a total of 400. The logic is going to be the same. Even though the numbers are more granular, the end result is the same. You just pick the lowest end-to-end cost along the path. So on switch 2, if we were to say, go to Fast Ethernet 13 and change the spanning tree MST cost, because it's specifically for this instance, and I'll set the cost to 100,000. When we now look at the detail of show MST instance 2 detail, it says now my total cost is 300,000. It's these two together for 300K versus these two together for 400. When we look at the MAC address table, we should see that it moved from, previously it was on port 19. This one had to be deleted from the table because now this interface is blocking. Can't have MAC addresses in the table. We should see when they send traffic to each other now, this should appear over 13. So again, the overall configuration logic is the same. Just when we look at the final syntax, the big change in multiple spanning tree is that you need this manual mappings of the instances. And this is why, from a migration point of view, usually it's easier to go to rapid per VLAN spanning tree first, because you don't have to change any of your root bridge placement, you don't have to change any of your cost values that you already did. You're just running the rapid algorithm now on a per VLAN basis. But for really large-scale deployments where the number of instances of spanning tree is the problem, that's what this is designed to solve, the MST. Here at the changing the bridge priority, changing the port cost, same logic, we're just doing it on an MST instance basis as opposed to the VLAN basis.
So what's in instance 0 right now? Nothing?
Everything else. So VLAN 1 plus all of the other VLANs that I didn't define yet. If we show spanning tree MST 0 detail, it's all other VLANs that are not 10, 20, 30, 40, 60.
When you migrate from rapid spanning tree to MST, what would cause some of your trunk links to still be bound to rapid spanning tree?
If it says, do you have it configured right now?
Yeah.
What rack number are you on?
15. For instance, switch 1, some of my trunks are still bound to rapid spanning tree.
It says here that we are running multiple spanning tree protocol. This is, it should mean that they're running, either it means that they're running rapid per VLAN spanning tree, or the instances don't match up. So first let's go to the other switches.
They're all running.
And let's say on switch 2, show spanning tree. Okay, these ones are running multiple spanning tree also. So is this one. And this one as well. It says that this is between switch 4's 19, 20, and 21, where physically in the topology this would be 19, 20, and 21 is going to go this way. So 19, 20, and 21. It's the same on the other side here, 19, 20, and 21. So there's some inconsistency between these two switches then. Probably what it is that either the instance mappings, that's what it is, the instance mappings are not there. So this on its own is telling everything to fall back to instance 0. And there's no defaults that it's inheriting from what should be under here. So you have to do this first, the MST configuration, to do the instance mappings.
Oh, you have to do that on each one.
You have to do that on each one, right. Because this is how they figure out if they're in the same spanning tree or if they're in different spanning trees. Okay, any other, go ahead.
What happens if he does it after the fact? He's got MST on all the switches. Can he now go back and put the instances on the switches that he didn't already do it? Or does he
You can change it, but the only issue is that it has to reconverge.
Oh, okay.
So as long as you do it, the migration like during a maintenance window, then it's fine. But if normal traffic is being sent, it'll be dropped temporarily as they resynchronize the network. Most of the time you'll see that it'll work itself out. The only issue is that when you have the multiple spanning tree domain that is talking to the legacy common spanning tree and talking to Cisco's per VLAN spanning tree, this is what an inter-region design would look like. So the way that they built the interoperability is that from the common spanning tree's point of view, there may be hundreds of switches that are in here, but they look like one. But in order to do this, the MST region needs to be in control of the topology. It needs to have the root in there. So if the root ends up in the common spanning tree or the root ends up in the per VLAN spanning tree, the interoperability falls apart and it can't build the topology. That was the original log message that switch 1 generated for me. It said that there was an inconsistency on the link between them. So you would just need to make sure wherever your root bridge placement is, that's where you migrate them to MST first, and then you can move out from there.